So again, today what we're going to do is just talk a little bit about some fractions, but specifically about fractions that have algebra in them. Remember, the only thing that makes algebra different from arithmetic is the introduction of those letters, those variables. So, and we're going to talk, the fractions that we're going to look at are fairly simple, but they go through the basic rules. But I'm going to talk a little bit more in depth because they're going to get bigger as we go. And I think it would be better if you had all the rules all in one spot. Okay? So the first thing we're going to do is talk about how to simplify or reduce fractions. Now, there aren't a whole lot in here where you're going to simplify or reduce, but it will come up later, and it's part of what we're going to do when you multiply fractions. So because these are algebraic fractions, in other words, they're going to be polynomial terms, the first thing is to always factor completely. Now, these that we do today are not going to factor, but then as we move forward, they will. So I want you to get around your head that any time that you have these fractions that have letters in them, if you can factor something, you should factor it. And I'm going to show you today also some. You need to be thinking along the lines of factors and factoring. Then you're simply going to divide out any factors that are common to both numerator and denominator. Now, you can write out numerator and denominator if you want to. This is the only place I use capital N and D or to stand for numerator and denominator. Okay, so let's just look at an example. And again, this one will not factor because these are monomials, meaning they only have one term. Okay, so we're just going to simplify it. So since there's no pluses or minuses, we know that they're monomials, one term. So that means they won't factor. So what we're going to do is just go through and take it piece by piece. First, we would do the signs, if there were any, but this one's a positive divided. Well, we'll go ahead and make that negative. What the heck, just for kicks. So a positive divided by a negative is going to make what sign?
A negative.
A negative, excellent. Then you'll do the coefficients, which the coefficients of a term simply mean the number. So 12 will divide evenly by 4, so that's not even reducing, that's just division. So 12 divided by 4 is going to leave you what?
3.
3.
Negative 3.
So, yep, and so we already have our negative there. And then do the exponents. Using rules for exponents, which we know very well. So x to the 5th divided by x to the 2nd is going to be x to the what?
3.
3rd, right? Good. And y to the 3rd divided by y to the nothing. Remember, if there's nothing there, you assume it to be a 1. And because we're dividing, we subtract. So y to the 3 minus 1 is y to the 2nd. Right? Just to kind of remind you of what happens. Now, they don't always divide evenly. So say we have 3 x to the 3rd, y to the 2nd, divided by negative 9 x to the 5th y. Okay? Again, we know it's division because of the fraction bar. So, but we can't factor this, and it's not multiplication or addition, so we're just going to divide. Positive divided by negative is negative. 3 won't divide evenly by 9, but they'll both divide by 3. 3 divided by itself leaves a 1. 9 divided by 3 leaves a 3. So that's going to leave a 1 in the top, a 3 in the bottom. X to the 3rd and x to the 5th. There's an x to the 3rd in both of those. So x to the 3rd divided by itself will divide away. X to the 5th divided by x to the 3rd is leaves x to the 2nd. But notice it's down in the bottom. If you use that subtraction rule, it would have been x to the negative 2. And remember, you now know that a negative exponent means that it shouldn't be in the top, but it should be in the bottom, right? Then y to the second divided by y to the first. They'll both divide by y. So y to the second divided by y will leave a y. Y to the first divided by itself will leave a 1. So that leaves a y in the top. And of course, since we already have the y, we don't need that 1. Look familiar?
Yeah.
Okay, bouncing back to you? Okay, good, excellent. And the reason we talk about simplifying fractions first is because simplifying is the most basic rule, and it's always the first rule of fractions. Because ultimately, that fraction bar means to divide. So that means we always should divide first if we can. Okay? So now we're going to move on and talk a little... Yes?
Sorry, question. When is it negative y over 3x to the 2, or is it negative y over 3x to the 2? Like, is it the
good
whole
question.
fraction?
You can put the negative in the top. You could put the negative in the bottom. But typically, we just put it out front. If you're using it, this is how you would use it. You always put the negative in the numerator in the top. Okay? So if you have a negative here, we just always assume it goes with the numerator. Okay? But if it in the answer, it would just hang out up front. Good question. Thank you for that. I forgot to mention it. Good job. Okay. So the first thing we're going to talk about, when you're dealing with operations with fractions, is the easiest ones to work with, and that is how to multiply fractions. And again, these are algebraic fractions, so the first step might surprise you. Well, actually, it shouldn't surprise you. I hope not. But anyway, the first step is to simplify. We get used to simply multiplying straight across and then simplifying what's left. But if you do that with algebraic fractions, they become huge very quickly. And you can dig yourself into a hole that you simply just can't get out of. So the easiest thing to do is to simplify first. And again, remember that when you simplify, first you factor, then you divide away common factors. CF to me always means common factor. Common factor, numerator to denominator. Okay? So that A and B part right there is what we did on the other page. But this one's heavily abbreviated. But remember, always factor first if it will factor. Okay? Now, but if we're multiplying two fractions, say we have some A over B times some C over D, that means we have at least two numerators and two denominators. So when we have multiplication, it's any numerator, oops, that didn't even look like an N, to any denominator. It doesn't matter which fraction it's coming from. So we could simplify A to B or A to D. As long as you're crossing that fraction bar, the division is allowed. So we could do C to B or C to D. And you must make sure you factor it and you simplify it completely. And then, with whatever's left, simply multiply straight across. Numerator times numerator, denominator times denominator. Okay? So let's just look at a couple of examples of that. And for those, we're just going to go straight to your book. So I'm on page 36 in your book. We're just going to do a few of these. Say we have something like number 2. So this is page 36. So number 2, we have 6xy over 5 times, I hate that they use the x for times, 2y over 3x. Okay? Now, again,
Write it down in time.
pardon me?
What was the last thing you wrote on the previous page? I didn't write it down in time.
To numerate, multiply straight across. Oops, I forgot the word across. Multiply straight across. Numerator times numerator, denominator times denominator. Okay?
Thank you.
You're very welcome. Okay, so here we go. We're multiplying fractions. So the first thing you should always do is identify the operation you're dealing with. We're multiplying fractions. And these are algebraic fractions, also known as rational expressions. So algebraic fractions. So that means the first thing we need to do is factor. But if you'll notice, all of these are monomials. If you had any pluses or minuses, then they might factor. For example, this one would factor. You could take out a common factor of 2. But if they don't have any pluses or minuses in them, you know they won't factor. So then that means we're simply going to divide away anything that's common, both numerator and denominator. So let me change color here. Very Christmassy. My first factor in the numerator is a 6. Well, 6 won't divide by 6 and 5 don't have anything in common. But because it's multiplication, I can also look to this side. What will divide into 6 and 3 at the same time?
3.
They'll both divide by 3. Excellent. So that's going to leave us a 2 there and a 1 there. Then the next factor up here is x. Is there an x anywhere in the bottom? There's an x there, right? Well, x divided by itself is just going to make a 1. So in other words, they divide away. And I don't need to write the 1 because I already have numbers there. Then the next factor is a y. Is there a y anywhere in the bottom? No. Now there's a y up there. Can I divide those two away? No, because remember, you have to be going numerator to denominator. You can't be going across right when you're dividing. You have to be crossing that fraction bar. My next factor is a 2. There's nothing that'll divide by 2 in the bottom. And then I have another y. There's no y in the bottom. So all I'm going to do is take whatever's left and multiply it straight across. So in the top, 2 times 2 is going to give me 4. And y times y is going to give me y to the second. And in the bottom, 5 times 1 is simply 5. Sound familiar? Hopefully.
Yep.
Okay, good
Yeah.
deal. Good deal. Okay. Let's just look at one more of those just to kind of refresh your memory. Look at number 18. 18 is a good one because it's got a lot of stuff going on, so it's a lot more like something you might see on one of these exams. So we have 5x to the second y in parentheses raised to the third power over 3y raised to the second power times 3x squared y raised to the second power over 4x to the third y to the fourth raised to the third power. Again, we're multiplying here. We're multiplying fractions. These won't reduce, but they all have something that they're parentheses raised to a power. Now, if they were parentheses raised to the same, if the base inside was the same, we could just treat them like, so to say it was 2x to the third power divided by 2x to the second power, then we could just use the rules for exponents and just say that that's one of them. That's one of those things to the third. 3 minus 2 would give us just plain old 2x, right? But because the bases here are not the same, we can't use that shortcut of simply subtracting the exponents. So what we're going to need to do is we're going to need to expand these. Okay? Now, you could leave the numbers in exponential notation if you wanted to, or you can just multiply them out and simplify them later. So 5 to the third is 5 times 5 times 5, which is what?
121.
Thank you. X to the 2 raised to the third power. Remember, when you have exponents on the outside, that's the only place where you ever multiply exponents. So x to the second raised to the third is x to the 6. Y to the first to the third is y to the third. 3 squared is 9. Y to the second is y squared. 3 squared is 9. x to the second is x to the fourth, y to the second. 4 to the third is 64. X to the third raised to the third is x to the 9. And finally, y to the, I can't even read my own writing, that's a y to the fourth. Y to the 4 times 3 is y to the 12th. Okay? And again, I had to expand it because the numbers were not the same. Now I can start dividing away anything that's common, numerator to denominator. And it's easy if you see stuff that's identical, like these two 9s. So you don't have to necessarily go in order if you don't want to. If you see something that's obvious, they're all going to simplify away in a minute anyway, or you can simplify some of them. So now look at these. 125 and 64. Is there anything that will divide evenly into 125 and 64? Just say no. It's going to be 125. The 64 is going to stay the same. Oops, sorry, don't be doing that. I'm trying to take a shortcut. X to the 6, there's no x in the bottom here, but there's x to the 9 in the bottom there. So x to the 6 will divide away, and this will become x to the third. Y to the third and y squared. The y squared is going to divide away. That leaves me a 1 in the bottom, and just a plain old y in the top. But if you look here, y and y to the 12th, those are both divided by y, so that's gone, and that becomes y to the 11th. Here, x to the 4th and x to the 3rd are both divided by x to the 3rd, so the 1 in the bottom is gone, and that becomes just plain old x. And then finally, y to the 2nd and y to the 11th will divide by y to the 2nd, so that's going to become y to the 9 in the bottom, subtracting the exponents. Okay, and then just multiply straight across, which gives us 125, and that's an x left in the top, and in the bottom, that's a 1 times 64, so 64 y to the 9th. So it looks complicated, but just take it piece by piece and really think about what it is you're working on. Now, in the back, they may have left that as 5 to the third, 4 to the third, because you see there was really no benefit to multiplying those out, but it doesn't matter. So you could leave those as exponents if you wanted to. Let me erase that so that it doesn't look quite so messy. Mm-hmm.
Write it out as it would be fully simplified before it's been multiplied through?
In this case, yes, you could have simplified it because, oops, sorry, that had the eraser tool on. Because the only thing that's simplified in this particular case were the 3's to the second, and there was a 3 to the second in here and here. So you could have simplified those first as if you saw that was going to be 3 to the second, you could have just left them as exponentials. But normally, what would have happened is they would have given you something where this and this might have simplified, but in this case it didn't. Okay. All right. So whatever you recognize, again, I know that you're very strong. All of you are very strong in mathematics, but I don't know your background, so I don't know. So I have to. I can't assume anything. I don't want to assume anything. But yes, you're exactly right. So remember, my process of working it is going to show every piece of detail. That does not mean that that's where you are. And so you do not have to show all of the work that I do. All right? So if you can see things then and simplify things beforehand, then be my guest. Okay? All right. So that's multiplying. Let's talk a little bit about dividing. Dividing is a good one because when you divide fractions, what you need to remember is that you can't. what you have to do is change to multiply by the reciprocal, or multiply and invert. So if you have A over B divided by C over D, that simply becomes A over B times D over C. And then, of course, you just follow the rules for multiplication. And that doesn't matter. And if you have multiplication and division mixed, then change the division to multiplication first, and then just treat it all as multiplication. Okay? And since it's the same, I don't think we need to go through any examples unless there's some on there that you want to see on those pages. What if it was like x over y divided by 2? X over y won't change. The division becomes multiplication, and 2 is going to become what?
1/2.
There you are. Okay. Just be careful. They're good. They love to throw in whole numbers so that you have to turn them into fractions when you do the reciprocals. Okay. All right. Now, the operations of multiplication and division don't typically cause most students much problems. The operations that do is adding or subtracting fractions. And I want to spend some time here talking about these because adding and subtracting fractions is also an important the pieces of adding and subtracting fractions are also what we're going to use when we solve equations that involve fractions as well. You need the same general ideas. So the first thing when you're adding or subtracting fractions is you must have do y'all call it lowest common denominator or least common denominator?
Lowest.
Lowest, okay, thank you. I want to make sure I'm using the terms y'all use. Lowest common denominator. Okay. You cannot combine, add, or subtract fractions without having a common denominator. Now, there are lots of ways to get a common denominator. If the denominators are very simple, most people simply multiply the two denominators together. I don't care how you find a least common denominator, but I am going to show you a process. And if you want to use the process, go for it. If you hate it, perfect. I don't care. But if you don't know some method, this method, find a method. Okay? All right. To find the LCD, okay? The first step, imagine that, factor completely. Again, remember that these are simple fractions that we're doing, but as we move forward, they're going to become more complex. So in order to find the LCD, you have to know what the factors are. So if it's not factored, you must factor it. B. Then what you need to do is find the lowest possible combination of those factors that still has every factor in it. And you can do it any way you want to. It makes no difference to me. I'm going to show you a process with using what's called upside down division, and it's just the one I learned. It's the one I like to use it. It's mainly for weaker students, so it's probably not something that you guys will use, but it's just a method. Okay? So, did I just tell you have to do it this way? Absolutely not. I'm never going to do that. Okay, so I'm going to use upside down division. And again, it's just a way of keeping it organized. To do that, first, and I know that I used one there and one there. don't yell at me about note taking. Okay, so we did the divide then multiply for each one of them. Took our LCD, divided by the denominator, and then multiplied what you got left times the numerator. That's where we got all of those terms, right? And again, they won't combine because they're not like terms, and so if they won't combine, then they're also not going to divide by a monomial. Okay? All right. So what I want you to do is practice some of those before I see you again. So we're going to give you a little homework. You're just going to do pages. Let's see where that starts. Adding and subtracting fractions, multiplying and dividing fractions. So 36. 37. Can't write down numbers, not a good thing in my business. 38 and 39. Okay. And then we'll start talking about working with equations, and you'll see exactly the same patterns happening again. Okay? So 36, 37, 38, and 39, it's quite a lot of them. So if you want to jump around a bit, that's fine. If it's just review, if you have trouble with any of them, then do more. Okay? All right, so let's stop.